Okay. So this section, it's not going to feel difficult when we're doing each individual part. Where most students felt like they had a harder time is virtually all of these are like written out problems, like situations. And they can feel so different from each other that some people have trouble identifying what it, which one that goes to. And I'm gonna guess that none of you have heard of combinations or permutations. And that's fine. I mean, you obviously heard of combination as a word before, just not like a math word. Before we get to them though, so we have to talk about something called the fundamental counting principle. And the fundamental counting principle is just, it's a way of finding out how many choices there are for things. Like if you go to a restaurant and there are 2 types of pop and 3 different types of pizza, how many different ways can you order? So then you would take 2 times 3. Yeah, I think I have it written on the next one. Yeah, no, I don't. Where's the word? Yep. So the fundamental counting principle, I'll write it on there. So in algebra 2, you'll start talking about when things are independent or dependent. So the fundamental counting principle only works when your choices are independent. And I'm just going to tell you guys that you'll only have independent choices. So like the example I said, where if there are 2 types of pop and 3 types of pizza, well, you choosing the pop has nothing to do with your choice of the type of pizza. So those are considered independent because one choice doesn't affect the other. And then you would multiply the number of choices of each thing to get the total number of choices possible. So like 2 types of pop, 3 types of pizza, there's 6 different ways you can order at that restaurant. And I currently have an example on the next page. Now, normally, I would tell you it really doesn't matter if you write down examples or not. Today, I'm going to probably recommend it because, like I said, this is what so many students had trouble with last trimester. Was they really had a hard time identifying which one should be what. So here's an example of the fundamental counting principle. And you don't have to know the name, you don't have to know the term.
Oh,
Hi.
sorry, I'm there. I got lost.
That's okay. I suppose you didn't know what the room was.
Yeah.
That one is okay, actually. Yeah, Alex sits there, but he's got it today. That'd be perfect. We'll just make that your spot if you want that. So florist has 2 types of vases, 2 types of plants, and 3 types of cards. When you're choosing these things, choosing the type of vase doesn't affect what type of flower you pick. Choosing the type of flower you pick doesn't affect what type of card you pick. And so in that case, you can just multiply the number of choices there are. So you would what, have 2, 2, 3? So 12 different possible combinations. And I probably shouldn't use the word combination. So the math part of everything that we're doing today is actually going to be pretty easy. I mean, like this one, we're just multiplying. Everybody just has a harder time identifying what, where's my mouse? There it is. Got to mark you here, otherwise I'll forget. There you go. Does it feel weird being back, right? A bit. You're my time set. You're done. Perfect. Why don't you guys try to figure this one out on your own? I can, sorry, I thought you were done. That's what I was trying to. Sophie's usually my guide across that. Oh, you doing, Jack? Okay, very good. Why don't you guys try to figure out this answer on your own? I think this is a password one or something like that. Yeah. That's up to you. I am gonna post these notes too, because there's so much writing in this one that I'll post it in case you just need them. So I'll leave it up to you guys what you want to write down today. I don't mind giving you the time to write down the problem if you're wanting to. But so you have to pick a password that's going to be a letter followed by a number from 0 to 599. Kelly, I feel like you should be allowed to call on the first person today because you reminded me about recording. Yes. I should have said other than Nora, but all right, I'll let it go this time. I should have known that choice was coming. I didn't ask anything yet. You've got nothing?
No.
How about how many letters?
I'd have to count them.
What? Oh my God.
No, it's 26.
Yes. You guys are supposed to know there's 26 letters in the alphabet. You can count them if you need to. Yeah. No, you're right. That usually would have to be specified. So this one's not intended to be that complicated. But you're right. Capital letters and lowercase letters are usually different. And so then that would be 52 different possibilities. So we're just going to pretend that that doesn't matter. But yeah, you're right. That is different. So there's 26 letters. How many numbers is this then?
599.
600.
600.
So I wrote it 0 to 599 because if I would have written 0 to 600, that's actually 601 numbers. It's kind of dumb. Let's make it go 0 to 1 is 2 numbers. So it's always kind of one bigger than that. If I would have written 1 to 600, then that would have been 600 numbers as well. I was trying to make an easy number to multiply. Although I say easy number to multiply, I can't do that. Yeah. You did it in your head, nice job. Well, let's just, we're gonna say you did it in your head. Okay. But the goal was, there were two different things that you had to pick. A 3-digit number, what you were saying was correct as well. This was supposed to be set up so that it was easier to choose, like, you guys are actually super familiar with passwords because you've had to choose them as you've been, like, your entire life. Anything electronic, you guys have had passwords for, so you're used to that. This is supposed to be meant for like somebody who's not familiar with passwords. A letter and then a number from 600 possible numbers. Otherwise, normally, it would be 1 to 999 or 0 to 999. Okay, so the idea though, fundamental counting principle, you just multiply the number of choices. So then we get to combination and permutation. I thought I had all this written down, but apparently not. Just making more work for myself. I'm gonna write it down first, if I'll screw something up if I try to write and talk at the same time. Maybe I should put pick in quotes. Because that's kind of a word that covers just about anything. The big difference between these two terms is one is where the order matters and one the order does not matter. So combinations is where the order picked doesn't matter. Permutations it does. Wait, 1, 2, 3, 4, 5, 6. So we have 16 people in here. And let's say we decide that we have 3 people are going to be chosen as class representatives, you know, to like go pick up stuff from the office or whatever, doesn't matter. If you get picked first, are you going to be considered different than the person picked third? No. So if you're picking 3 representatives, it doesn't matter which order you get chosen or picked. So first, second, third, second person, third person, they're just a group of 3. So some people like to think of combinations as groups because a group, they're all equal, right? But if we talk about permutations, let's just say we'll stick with our same class and we want to pick a president and a vice president, which would be done. But let's pretend that we're doing that. Maybe we'll say captain and a, there isn't really an assistant captain, is there? It's usually co-captains, but they're equal. Okay, we'll go with president, vice president. So in that case, the person that got the most votes, like the first person chosen, would be the president. The person that got the second most votes, the second person chosen would be vice president. And so the order you were picked would matter in that situation. So that's called a permutation. So when I mentioned groups for combination, that word for some people kind of, it helps them click that they're considered different that way. So we've got three situations up here. And we're not even going to calculate them yet. But that's going to be the next strategy, is teaching you how to find the answer on the calculator. Because this section is actually a whole world of difference if I make you have to figure out by hand, which you used to have to do. But the MCAs, basically our state standards, no longer require you to have to do it by hand. So in Algebra 2, you might be taught how to do it by hand, but not this year. So a street vendor sells cashews, peanuts, and almonds. You are planning on choosing two types. Does it matter which one you choose first? That's kind of what you should think to yourself. So no. So on this one, no order. Okay. Right here. There we go. No order. This would be a combination. And I'm trying to remember which number goes first now. The first number should be the highest. So there are three types of nuts being sold. We're going to do a combination of two of them. So this would tell us how many different possibilities are there for choosing two different styles. I'm pretty sure there's only three, but we'll figure that out. Karen is painting her bedroom. I stole this one out of the textbook. And then you realize Karen has a very different meaning now. But I thought this was fun, so I left it out. So Karen is painting her bedroom. She has orange, green, blue, and purple. So she has 4 different colors of paint. She plans to use one color as a base coat and one color to stencil something. Does this one match? So she has to choose 2 colors, right? The base coat and the stencil. Will this one matter? Which one is which?
No.
So like, you have to paint the base coat first. Can you do the base coat on top of this thing? No. So like on this one, your base coat is going to be one certain color. Your stencil is going to be one certain color. So because they do matter which one you're choosing first, like most people would consider the base the first one, but it doesn't matter. They're considered separate. They're not, you're not just choosing 2 colors. It matters which color is for which. So orange green is different than green orange. That's kind of what you're choosing, or you're choosing that word. That's kind of what you're deciding in your head. So this one does have an order. This would be a permutation. And when we go to calculate it, what we would do is we would say there are 4 colors, permutation, 2 of them. And this would tell us how many different ways you can pick colors according to that situation. Sandwich 2 of the following ingredients. Probably the worst sandwich ever, but mushroom, eggplant, tomato, and avocado. And this one isn't supposed to have like loopholes and stuff, you know, like I'm sure some people do consider what order you put the toppings. Some people probably think that matters. This is just supposed to be plain. If I pick 2 ingredients, mushroom and eggplant, it's no different than eggplant mushroom. So on this one, there would be no order. How many were there? 4?
Yeah.
Combination, 2 of them. Now, because every single situation is going to be set up differently, this is why students have a hard time with this section. Because when we get to the test, right, It's gonna be a totally different answer whether you choose a combination or permutation. The way the test is gonna be set up is you're gonna be given one question first, like a situation, that'll say, is this a combination or permutation? And then the second question would be the same situation, but having you actually calculate. And so that because of that, like if you get the combination or permutation wrong, obviously your second answer is going to be wrong. So because of that, the test scores varied a lot on the practice test. So this is kind of why I have 2 days of us reviewing and practicing. Because the first day you're going to do this, I'm going to go through and put notes on all of your answers. So the ones you did incorrectly, you can see how come. And then we'll take the review second, like a different set of questions, the next one, and see how that goes. Okay. I kind of already put this up there, but if you have a permutation, this is how it's usually written, or like this is the notation you'll see. The first number is the total number of things. The second number is how many you are picking yourself. And I've got to get the calculator open up on the screen here. And then combinations is going to be the exact same definition, except it's a C. And that's really going to be the only difference in the notation. Oh, I guess I have examples first. Okay, so it says the club will choose a president, vice president, and a secretary from 8 people. So we've already talked about this example, how the order that they're picked matters. Like if one person is the president, the other is vice president, you can't swap the two and then say there's, consider them different. How many ways, so that's the sample space, can the club choose 3 officers? So the order matters. This is a permutation. So I suppose I got to go up there to write it. We're going to be trying to do this on the calculator. 8 people, permutation because they're ordered, and we're picking 3 of them. So we want to find that number answer. If you have the calculator like this, I think that one's the same. There's a button that says PRB for probability. So usually the scientific calculators have a button for probability. If you have the graphing calculator, you're going to hit the button on the left that says math. Okay, come on. Okay, I'll clear out that so it doesn't look so scary. On the left-hand side, it says math. And then you should have a column that says PROB or PRB, depending on, I think one of the calculators, they shorten things up. But it's a probability section. And when you go there, you should see NPR and NCR, kind of exactly what we just did. So I'm going to pick the one that says NPR. Now on the graphing calculator, you're going to type the numbers in after you push the button. This is why knowing how to use your calculator will be helpful. If you have a scientific calculator, you probably had to type the number 8 first. It's annoying, the differences. So if you're using a scientific calculator, you're going to have to hit 8, then go to the probability button, and then hit NPR, and then 3. And you should get 336, depending on if you put it in your own calculator correct. So I'm kind of showing the graphing calculator because that's what everybody's got on their Chromebooks. And I know some people can't stand using that. So I'll help you out on your calculator if you need it. Did you guys all get yours figured out? Yeah.
After you do this, so I'm on the 2, then what do you click, like the NPR? Let me see.
Yeah, click NPR. So you can either the down arrow and hit enter, or you can just type 2. And like the keys on your keyboard even work.
Okay.
So once it pops up, it should have 2 blank squares with a P in the middle.
Yeah.
And so you're just going to go move the cursor to the first box, type an 8, and then to the second box and the 3. Oh, is there anybody who wasn't able to get that on their own? And to be blatantly honest, this is all the harder it's going to be math-wise. Like just knowing how to type the button in. I would probably write a little note to yourself though, in your notes. Because usually what happens is by the time we get to the test, even though it's like the practice one is tomorrow, everybody forgets where the button is. So if you're using the graphing calculator, hit the math button, scroll to the right to probability, and then pick NPR or NCR. And I would bet I have another example. Why don't you guys see if you can try this one? I suppose this isn't even a thing anymore at all. I would bet every single person just hooks up their phone to a stereo if there's a stereo. I suppose everybody just uses a Bluetooth speaker now. Does anybody have actual stereos in their home still? What, really? That was kind of half the fun, was people fighting over who got to choose the music.
So it doesn't matter which ones you choose as first, because that's like the ones it's gonna play.
Yeah, it doesn't really specify up there, but there's going to be a certain order to which ones are, like the first CD you pick is going to be the first one played. Because I'm assuming they'll just pick the CDs as they play them. Maybe it's only a 4-hour party, so they can only have 4 CDs or 4 albums. So this one is still considered permutation. And the answers start to get really big once the numbers start getting bigger. I mean, 7 and 4 doesn't seem like a big number, but that's an awful lot of different ways you can pick them. Now, if they're grouped together, it goes down by quite a bit. Like if you're just picking a group of 4 CDs and then the order doesn't matter, well, then that answer goes down considerably. It's like only 200 or something. I don't know if we even need to do this example or not. This one is supposed to be semi-obvious because when you line up for a picture, there's generally an order. Whether you want the tallest people in the middle and the shortest on the outside or however you want to do it, there's usually an actual order to pictures. The key word in this one is when it says the lineup. On the test itself, I tried to do my best to use words that made it feel clear if the order mattered or not, but this one would be a permutation as well. Okay, combination, if you need to write this down, I don't know. basically it's just explaining the button that you're using on the calculator. So NCR, the N is the larger number, the R is the smaller number. The number on the right can't ever be bigger than the number on the left. And then I'll have an example for combinations, which same kind of a choice I talked about at the beginning of the hour. A club wants a 3-person committee. There's only 8 people in the club. So the 3-person committee, because they're a group of people, the order that they're picked would not matter. So this would be considered a combination. So for this one, oh, go ahead. Do you want me to move back? Okay. Oh yeah, what, 8 people? So instead of picking NPR, I'm going to pick NCR, which is the 3rd choice. 8 people, a group of 3 for the committee. So once you get used to the calculator you're using, you basically are only going to use those 2 buttons. And it will not, the math part will not be difficult. What's difficult is trying to figure out which button to use. And that sounds dumb to say out loud, but that's where everybody's making mistakes if they do. So this one, there's 56 different possible committees that could be made. Okay, you go grocery shopping and there's a lot of cereals on the racks, but you basically have space for 4 on your shelf. 4? 4. You only have space for 4 on your shelf. You don't care what order that you pick the cereals, you just have 4 cereals that you're going to buy. So there's a good chance your parents are probably going to buy the 4 that are on sale. Unless you're really particular about cereal, and then, you know, maybe you have to have Fruity Pebbles or Captain Crunch. Even though we all know peanut butter crunch is much better. Do you guys eat cereal? What kind do you guys go for? Just whatever's there?
Special K.
That one's not bad. With strawberries? Yep, that one's better. Special K by itself is not great. With strawberries is actually pretty good. Nobody has any fun cereals they like? Which one? The Reese's Puffs? Yeah, that one is good. I can't argue with that. Nobody's like a plain Cheerios person? Really? That's impressive. Like not even Honey Nut Cheerios?
No.
You put sugar on top?
No.
Wow.
I like that too.
I'm impressed. I can't do it. I've tried it before. Just can't do it. Okay, so on the calculator, this would be 11C4. I probably don't need to put it up there, I'm guessing. You guys are probably okay with the buttons by now, because you do the same thing every time. But this one's a combination because the order doesn't matter. Basketball team has 12 players who can play at any position. And it specifically says can play at any position because obviously the center, the point guard, they're all different. But apparently we have 5 people who can play whatever. So because of that, when you just choose 5 people, that's the 5 people on the floor. They are a group. They can rotate to whatever. If this situation was different, where it said you had to pick the center, power forward, point guard, whatever you're choosing, then they are separate. And so then it would be a permutation. This one's a combination because they are a group of people. I think that's it. Yes. Yes, and you'll find for sure that these 19 questions don't have much work on them. I am 100% going to ask that you guys stop writing down the answer key as your homework that you're turning in. Because like that one from Friday, there are a lot of people that just wrote down the answer key, and the answer key has answers written differently than we even did in class. Like some of you didn't write any work, but I knew you did it by hand, or I knew you did it on your own because your answers weren't written like the answer key, and or you had like fractions that weren't reduced, things like that. But like a lot of you wrote all the answers as percents because the answer key had them that way. And we didn't really do that. And if you do a percent, chances are you probably had to do some extra work. Okay, so either way, my point, write down some things next to your answer. Don't just write the answer key. That's all I got. Let's stop recording before I forget about it.